Greetings, eco-nerdlings. In this podcast, we're going to be discussing solutions to reducing greenhouse gases and gas emissions. So now that you've heard all about greenhouse gases, the greenhouse effect, and global warming, what's actually being done to reduce all of this? Well, getting countries to agree on reducing their greenhouse emissions is very difficult. However, in 2006, a poll showed that 83% of Americans actually wanted more leadership from federal government on dealing with global warming issues. So there was an international climate negotiation that took place, and it called it the Kyoto Protocol. This was a treaty on global warming, which the first phase went into effect in January of 2005, with 189 countries participating. Of course, we were not one of those. It required 38 participating developing countries to cut their emissions of carbon dioxide, methane, and nitrous oxide to 5.2% below their 1990 levels by the year of 2012. Developing countries were excluded, and the United States chose not to sign. However, California and Maine are actually participating. The United States claimed that it did not sign because developing countries such as China, India, and Brazil were excluded from this protocol. So let's move beyond the Kyoto Protocol. Countries could work together to develop a new international approach to slow global warming. The Kyoto Protocol will have little effect on future global warming without the support and action by huge populated countries such as the United States, China, and India. So actions by some countries, states, and businesses are positive. In 2005, the EU proposed a plan to reduce carbon dioxide levels by 1/3 in the year of 2020. So California has actually adopted a goal of reducing its greenhouse gas emission to 1990 levels by the year of 2020 and by 80% below by the year of 2050. Global companies such as BP, IBM, and Toyota have also established targets to reduce their greenhouse emissions by 10 to 65% to 1990 levels by 2010. So what about ozone depletion in the stratosphere? What are some of the effects of that? Well, less ozone in the stratosphere allows more harmful UV radiation to reach the Earth's surface. The ozone layer actually keeps about 95% of the sun's harmful UV radiation from reaching the Earth's surface. Chlorofluorocarbons have lowered the average concentrations of ozone in the stratosphere. So in 1998, CFCs were no longer manufactured. So during 4 months of each year, up to half of the ozone in the stratosphere over Antarctica and a smaller amount over the Arctic is actually depleted. In 1976, in Antarctica, ozone layers have markedly decreased during October and November. And there's a lot of ozone thinning that is taking place, and this is caused by chlorofluorocarbons and other ozone depleting chemicals. Increased UV radiation reaching the Earth's surface from ozone depletion in the stratosphere is very harmful to us humans. It's harmful to crops, it's harmful to forests, it's harmful to other animals, not just us, and the materials that we have or have created, such as plastics and paints. So let's look at some of the effects of ozone depletion on various factors. First of all, on human health. It can increase very bad sunburns, which can lead to different types of skin cancer. It can increase eye cataracts, more types of skin cancers, and it can also suppress our immune system, so we won't be able to fight off infections as good as we could if our immune system hadn't been suppressed. It can cut off food and forests, so it can reduce yields for some of the crops. It can reduce seafood supplies from reducing phytoplankton, and it could decrease forest productivity for UV-sensitive tree species. As far as wildlife goes, it could increase eye cataracts in different species of organisms. We could see a decrease in the population of aquatic species that are sensitive to UV radiation. And we could also see reduced populations of surface phytoplankton, which will in turn disrupt aquatic food webs and food chains. We could see air pollution and materials that will increase in acid deposition. We'll see an increase in photochemical smog. We'll also start seeing degradation of outdoor paints as well as plastics. And we'll see global warming that's occurring and accelerated warming because of decreased ocean uptake of the carbon dioxide from the atmosphere by phytoplankton and chlorofluorocarbons acting as greenhouse gases. So with all of these negative things, we have done some positive things to help out with global warming. So we do have emission control devices, which are filter particles out. We have scrubbers, which use water to filter particles and gases. We have catalytic converters, and these occur on cars, and they finish burning waste to decrease carbon monoxide levels. We also have established different types of laws. So we have a law called the Clean Air Act, and this was first passed in 1963, and it was amended in 1970, 1977, and 1990. It also involves the Environmental Protection Agency, and this sets standards for acceptable levels of sulfur oxides, nitrogen oxides, ozone, carbon monoxide, hydrocarbons, lead, and many more types of chemicals. It also provides pollution credits for industries that utilize pollution control devices. However, the Bush administration relaxed some of these rules, and that's something that we spoke about a little bit earlier. It established the NAAQS, which is the National Ambient Air Quality Standards, and the AQI, which is the Air Quality Index. So the NAAQS sets acceptable concentrations for 6 criteria pollutants that threaten public health and the environment over broad areas like non-point pollution sources, pollutants that are emitted in large quantities and include carbon monoxide, lead, nitrogen oxides, ozone, and particulate matter, as well as sulfur dioxides. We also have the Air Quality Index. This measures the levels of 5 criteria pollutants, and we actually have forecasts on daily air pollution levels. And the purpose of this is to educate and protect the public, and it focuses on the health effects of these pollutants. So categories are green, which means good, yellow is moderate, orange is unhealthy for people that are sensitive. So it might be, depleted ozone, so people that have very fair skin, they might have a warning, you need to wear sunscreen. If there's photochemical smog or something like that, it might apply to people that have respiratory infections or respiratory conditions such as asthma that might be irritated. If it's red, it's unhealthy, and if it's purple, it's very unhealthy, and a lot of times they'll actually tell people to stay indoors. And we have national emission standards for hazardous air pollutants, and this regulates emissions from point sources, meaning they're specific. And those are specific substances for air toxins with known or suspected serious health effects. So meaning things that can cause mutations, that can cause cancer, or that can cause different types of neuropathies. And we call those mutagens, carcinogens, and neurotoxins. And they tend to be localized from point sources. And examples of those are ammonia, chlorine, asbestos, arsenic, mercury, and benzene. Well, I hope you learned a lot about air pollution over these series of video lectures. If you'd like to rewatch any of these or any other lectures for APES, you can find them on my website at www.nerdlingscience.com. Well, this is the Queen Nerdling signing out. Stay nerdy till next time.